Okay, welcome back everybody. It's Monty here, and we're on week 36. We're the 7th and the 8th, and we just did our part 1 where we learned about the fundamental counting principle, total number of combinations. Okay, so let's go to our I do, we do. Now, word problems. We need you to slowly try every problem, and don't worry about your answer, worry about your ability to work through what you understand it to say. Okay? We're going to show you the teacher way, but it's more important when you're doing these doing these problems on your own, that you think about the concept. Does it make sense to you? And then try to verbalize it. Not always an easy task. All right. Determine the probability of each event. Probability of the event. And its complement? What? Huh? Okay. Vocabulary. Okay. Spinner. We've all spun a spinner, right? Played Twister. Now, probability of greater than 7. Now remember, the probability of an event is the outcomes we want over the total number of outcomes. The total number of outcomes. All right, let's do it. So the total number, and we want. Okay, and this other one will be what we want, and the total number. Well, the first thing I want to do is get some partial credit here. I want to know how many total there is. It looks to me like it's divided up like a clock. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 on the bottom. We automatically get half the problem right. Okay. Now, greater than 7. Greater than 7, not including 7. 1, 2, 3, 4, 5. 5. Done. 5 out of 12. 5 times out of every 12, we should get the answer we want. Cool. Not greater than 7. Not greater than. Not greater than. Less than or equal to 7. All the others. 1, 2, 3, 4, 5, 6, 7. Okay. Cool. We put them together, we would get the whole thing. So we have everything bigger than 7 and everything not bigger than 7. Okay? All right, let's move on. Now, you choose a ball at random from the box. What's the probability of getting a 5? Now, it looks to me like they have this broken up. 3 times 4, there's 12 total. 12 total. What we want a 5. How many 5s are there? 1, 2, 2 of them. 2 out of 12. Done. Now, whether it's Mathia or computer, they're going to want you to simplify half and half. 1/6. Okay? Probability not a 5. Everything else. Everything else. If you write that, partial credit. Everything else. So if there was 2 that worked, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. 10 out of 12. Done. Again, push yourself on simplifying. Half of 10 is 5. Half of 12 is 6. Good. Let's keep moving. Okay, now I'm going to pause. You read it. Figure it, and then let's compare. Read it, figure it, compare. Read it, figure it, compare. All right, welcome back. The total number of balls is 30. Done. As soon as you see the total, 30 is the total. 30 is the total. half of which are shaded. You choose a ball from random, half. That's 15. So, shaded, 15 to the 30. 1/2. Not shaded, the other half, 15 to the 30. Okay? Any of these answers work. Okay? Push yourself for partial credit. Alright? Now, using the counting principle that we learned, determine the number of possible outcomes for each situation. Okay, again, we want to pause the video, you try it, and then, I'm sure that we're 25 minutes into class, this video is 5, I'm rolling along, you had some sort of a discussion. I think this should be our last problem, and then we'll come back on Wednesday, Thursday for the rest of this, okay? Using the counting principle to determine the possible outcomes of each situation. There are 5 students. 5. One day. How many independently read their essays? There are 5 students scheduled to read their essays aloud in class one day. The teacher will randomly select the students. Order. How many different ways are there to read the essays? What? We have 5 students. Students. We have 5 of them. A, B, C, D, E. Oh, random. Oh boy, there could be a bunch, huh? Wow. A, B, C, E, D. A, B. Now we go A, B. We flop these 2. Now we've got to put that up there. D, C, E. A, B, D, E, C. We got to keep doing that and doing it and doing it? Are you kidding? A, B, D. Okay, so now the D has to go to the B. The D has to go to the B. Can you guys start to see the pattern? D, B, C, E, A, D, C, B, E, A, D, C, let's see, C, D, E, now C, E, B. Can you see how many there's going to be? Wow. Okay, so we know E and D have to flop, right? 2. Now we put the D, we brought the CE, and then we had to flop them. Then we brought the D, and we had to go B, 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 C, 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 right? And we had to flop them. Okay, fundamental counting principle. F, C, P. The fundamental counting principle means 5 in the group. How many possible combinations? 5 times 4 times 3 times 2 times 1. Serious. You don't have to rotate this. 2. Okay, when there's 2 of them, 2 times 1, right? There's 2 combinations. 3. When you have 3, 3 times 2 times 1. When you have 4, 4 times 3 times 2 times 1. And when you have the 5, we keep going and we keep going and we keep going and we keep going. So 5 times 4 is 20. 20 times 3 times 2 times 1. 3 times 20 is 60 times 2 times 1. 120 combinations. Wow. Combinations. Easy for you to say. Combinations. Combinations. What? You guys spell combinations, and we'll see you on Wednesday, Thursday. Bye, everybody.